So back in week 2, we learned about the different variable types in C. We learned about int and char and a couple of other data types. But I didn't go over arrays at that time because technically C doesn't have an array data type. Instead, C uses a concept called pointers. Pointers are a little difficult to get your arms around if you haven't had to deal with them before. So I'm going to take it slow in this section. But I hope you'll find at the end, pointers become a little bit natural, and they're actually a very powerful way to leverage your computer system. Why does C use pointers, by the way? So when C was first created as a computer language, computers were not very powerful, and they didn't have a ton of memory. And so the best way to leverage the memory that was there was to use these pointers. Pointers, you can kind of think of pointers as a way for the system to say, this variable is this variable, but its memory is actually over there. It like points to where its memory is really located. That's very handy when you need to have arrays, especially if you need to change the size of an array, because then you can move memory around and things can happen kind of behind the scenes, and you don't have to worry about quite too much about what's going on, but you do have to know where the memory starts, and that's where the pointer comes into play. So there's a couple of different ways that you can use arrays, and I'm going to actually start with a very simple way to create an array. So let's go ahead and do a very simple test here. So we're going to create a very sort of simple array that's of a fixed size. So let's do test here of we'll just call it array. Now, standard way we've been writing our programs, we always need to start with the include standard IO, and then our main function int main, and then the curly braces. So how do you define an array? Well, remember the way that we created a single variable was we declared its type, like an integer, and then we declared the name of the variable itself, like maybe numList, right? And that's all we did to define a single variable. Well, to make that an array, you actually want to put brackets. And there's some stuff that happens behind the scenes. We're going to hear about that in a little while, but that's one way to define an array. We want to do this of a specific size, so we're going to tell it right now how big that is going to be. So we're going to say that's 10 elements long. Now, we could just leave that definition like that, and what that'll do is that'll just define an array of 10 elements long, and it'll sort of leave room for that in the memory. Another way that we might create an array and assign something to it at the same time is we could do int, let's do this as 10 list, right? And I'm not going to tell it how big the array is, but I am going to initialize it. Remember that we said we could initialize an array or initialize a variable by just giving it a value right away when we defined it. Same concept with arrays. I'm going to tell the compiler that this is an array by using these empty brackets, and now I'm going to assign a value to it. Now I'm going to assign a list of values to it. I need to put that inside these curly braces. So let's go ahead and define my array. We're going to give it commas to separate the individual values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these two arrays, numList and 10list, they are the same size, right? The numList has 10 entries in it. 10list has 10 entries in it. And then I'm going to need a variable to kind of run through my array, so I'll just call that one int I. Now, how do you reference the array? Well, we can go ahead and print out the contents of that 10 list. So let's print the contents of the array. And let's go ahead and loop through for I equals, now where do we start? How do arrays start? Well, in some other programming languages, arrays start counting at 1. Like the first element in your array is element 1. Not the case in C. C starts all arrays at 0. So we're going to start counting from 0. And then I is going to be less than 10, or another way to say that is it's going to be less than or equal to 9, because 0 through 9 is 10 elements, right? And then I equals I plus 1. And let's go ahead and just print out the elements of 10 list. So let's go ahead and say printf, and we'll just say 10 list, and then inside the brackets we're going to actually indicate what the element is, and then what the actual value is. Let's go ahead, and then a new line. Let's go ahead and put those in. So I is the first variable I want to put in there. And now I want to print out what the array element actually is, and that's 10 list I. So whenever you reference a variable or an element in an array, give the name of the array, and then with square brackets, give the actual element in the array. And that will print out the elements of the 10 list. We're going to go ahead and return 0. We'll come back to this program here in just a second. So I'm not using numList right yet. I'll get back there in a second. In fact, I'll go ahead and get rid of it. So let's go ahead and compile this program. Save and quit. Remember, we do I16 GCC. We're going to turn on all warnings. We're going to output array.exe, and we're going to go ahead and compile array.c. And if I don't have any errors, I should get a prompt back. So let's go ahead and run array, and that should print out the contents of the array. And remember, it's going to start the array at 0, and the elements that I stored in there was 1, 2, 3, 4, 5, all the way up to 10. There you go. You can see that it starts at 0 and goes to 9, and those are the array elements, or the data that I stored into the array in order. Let's edit that, and let's actually copy values from one array to another. So let's go ahead and create my num list, and that's going to be of size 10. And let's go ahead and copy. Let's put in an instruction here to actually copy an element from one to another. And the way that you do that is just the way that we do variables, right? In variables, you'd say A equals B, right? That's a way that you would assign to the variable A what's in the variable B. Same concept for arrays. So we're going to say numList I is equal to 10 list I, right? For every element in the array of 10 list, store that in numList. And so now I want to print out the value. numList, we'll just say is now that. Let's go ahead and change the reference over here. So before I compile this, let's remind ourselves what's going on. So I've got an array here called numList. I didn't give it any values in the array. I just told it it was going to be 10 elements long. And then I defined another array, a slightly different way of defining an array, where I didn't give it the number of elements, but I did initialize it. And so C is able to work from that to figure out how many elements should be in the array. It walks through it and knows that there's 10, and so it was able to reserve 10, enough memory for 10 elements in that array. And then here's my counter variable. And then I walk through 0 through 9, and I'm storing values from 10 list into numList, basically copying it, and then I'm printing out the value of numList. Go ahead and compile that. And if I don't have any errors, I should be able to go ahead and run array. And exactly what we had before. So we're able to define two arrays and copy data between them. And that's how you, the simplest way to define an array. Now that's an array of fixed size. We're going to learn a little bit here how to change that. So now that we know how to do arrays, it's actually now possible to do strings. You remember back in part 2, we learned about the different types of variables. I mentioned int and char. Well, char stores one letter. An array of chars will be a string. And you do it the same way. So let's go ahead and do another test here. And I'll just call it strings.c. Again, let's go ahead and start with include standard IO and our main function. So let's go ahead and just do a sort of a very simple hello world here. Because there's something that you need to know about how strings are stored in C. Let's go ahead and start with a simple character array. And we'll just call this variable hello. And it's an array of characters, so we need to use the square brackets. And we're going to initialize it with a string. Now, you could do the list thing that we did with numbers, but a handy shortcut is to use double quotes to actually put in a value. And so we're going to put in the value, we'll just say hi there with an exclamation point. So what have I done? I've defined a character array. It's an array because I got the square brackets, and that array is called hello. And at the time I've created it, I've assigned this value to it, hi there, everything that's inside the quotes. So when I print that out, I could just print it out using puts. In fact, I'll go ahead and do a puts of hello. But another way that you can print strings out is to do printf, and you would use %s. That actually prints out a string. Now I want to put this inside brackets just so I can kind of see where the string begins and ends. We'll go ahead and do our new line, and then what's the variable we want to put in there? It's hello because that's an array. At the same time, let's actually count out what's in there, right? So do you remember that I'll put this inside these brackets again. So we're going to count characters, counting characters. The characters themselves, let's put in some letters here. It should be 9 characters long. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm putting this in here so that way when we look at the string hello being printed out through this printf, we'll see just some numbers below it. And that'll allow us to count the characters. It should be 9. I think I've counted out correctly. And then remember, arrays start from 0. So 0, 1, 2, 3, 6, 7, 8. And so these are positions in the array. Let's go ahead and return 0. That's the end of it. So we'll go ahead and save and quit. I16 GCC, turn on all warnings. We're going to output this as strings.exe. And we'll go ahead and file the strings.c. Didn't make any errors. There we go. Strings.exe. So it's printed out hi there. So I can print it out just as a string through puts. I can also use printf with the %s. Now, I put in those brackets so we can kind of see what's going on, right? Counting characters, there's clearly 9 characters in that array. And counting positions in the array, right? Array element 0 is capital H, array element 1 is lowercase I, and so on. But it turns out this is actually, this array is actually 10 characters long. What you're not seeing is an ending null value. And so how does C know that a string is done? So it knows where to start by pointing, because that's the beginning of an array. But how does it know where a string ends? Well, C uses what's called a null terminated string. It terminates with a null. Let's go ahead and do an update to this. Strings.c. go ahead and do an update this so I can actually show you what I'm talking about. We're going to create a simple function here called string length, right? And that's going to be it'll take a value string, which is an array. How do I know it's an array? Because I'm using the square brackets here. And so how do I define this function? Well, I want to print out the length of it, or I want to return the length of it. So I need a value to count with. That's going to be the length of the array. I'll just call it length. We'll start that out at 0. Now, how do we know the length of a string? Well, we need to walk through the string until we find a null character. And what is a null character? Well, a null character is \0. That's the escape sequence to generate a null character. I talked about some of these escape sequences in the programming guide from an earlier section, and I think null was in there. If it's not, I'll make sure it's in the programming guide going forward. So let's go ahead and walk through this array. So how do we walk through the array? Well, we could do a for loop. We could do it a different way, but let's actually do it with a while. And so as long as in the string, whatever position we're at, len, isn't a null value. So characters are always put in through single quotes, not double quotes. Double quotes always indicate a string. So if I did this as that would be a different thing. The double quotes implies that's a string, but I want to do a single character. So characters are always inside single quotes. And this is a single character by itself because the \/ indicates this is a special thing. And after that is a 0, and that indicates that's a null. So as long as that position in string is not null, we're going to go ahead and do some stuff. And so what are we doing? Well, we're just going to add 1 to the length. That's all we're going to do. Literally, all we're doing here is we're just starting out with len is 0, and then starting at the 0th position, because len is 0, we're going to just walk through until we find the null character. And when we're done with that, we're going to go ahead and return the value of len. So let's go ahead and update our program down here to actually use that. So let's go ahead and create a variable here called hello len. And down here, let's go ahead and put hello len is the value of the function's string length with the value of what's stored in hello. Then go ahead and do printf hello is that many characters long. And that's the value that we got out of hello. Okay, so that's what we're doing on this. So we're going to just do this test by we've got our string hello, and got an integer that's going to just store the length of that. We can get rid of that standard print here. So here it is printing out the value inside these square brackets. I'm still going to keep these because that's a reminder about what we know is actually happening. And then this is going to just call the string length function that we've defined up above. That'll tell us exactly how long it is, including the null. And it's going to print that out right here. Save that. Let's go ahead and compile that. So let's go ahead and run that program and see what happens. So it's 9 positions long, but counting on the counting characters, it's 9 characters long. The positions in the array goes from 0 to 8. but that's because we're not seeing the null at the end. The null at the end is kind of hidden because that's what C is using to mark the end of that string. Is using the null. So it really, hello is going to be 9 characters long. And that's true of all strings. It doesn't matter how long we made that string. Let's go ahead and do one more test on that. And instead of hi there, we're going to say hello world. These are no longer going to really be helpful because it's going to be much longer than that. Let's go ahead and save. And if I compile and then run, oops, then run, you can see that hello world is 12 characters long. And if you count those out in your hand, you'll notice that hello world with the exclamation point is exactly 11 characters long, but there's a 12th one sitting out there that is the null that we can't see. Now we did that by using a function that we wrote called string length. By the way, I should mention that there's actually a function to do that in the standard C library. Right? That's a very useful thing to do, and it's a very similarly named function, and that is strlen, which is not defined in standard IO. It's defined in another include file, and that is string.h. And let's go ahead and compile that just to remind. The whole time I didn't put in a yes. Let's go ahead and save and quit. Let's compile that. So I16C, and all warnings. It's going to be in strings.exe, strings.c. Oops, strings.c. And I didn't make any errors, so that's good. So we'll go ahead and run strings, and you get the same output because we're using a function in the standard C library that does the same thing as our string length function. It's strlen. So that's kind of our basic introduction to arrays and strings, but I haven't gone into pointers. So with that basic knowledge, let's do a quick let's do an introduction into what happens with a pointer. Now, I'm going to do a demo here just so I can talk about what pointers are. So when you do a program that uses pointers to store memory, you're going to need to do a couple of things. And as we defined the variables before with the square brackets, C was doing some things for us behind the scenes, but using pointers, ourselves manually, we need to do some things in a certain order. And so what we need to do is we're going to first need to declare the pointer to an array. It's a little different than just using square brackets. Although behind the scenes it's the same, but we're going to actually learn about using the declaring a pointer to an array. We're going to need to allocate memory enough to store all the elements in the array. And then we're going to need to set the pointer to indicate that memory. That's what we need to do as part of writing a C program that's going to use pointers. Let's go ahead and put that in a comment block so we have it as a reference. So let's go ahead and write a program, a sample program to do that. So go ahead and do our include standard IO and our main function. Now, we did a very simple example before of a simple number list. So let's go ahead and stick with that. So we did int numList, and we did a square brackets like, and we could do that here, but when you're doing an array and specifically declaring as an array, we want to actually use a specific pointer. And so we're actually going to use this as a star. So as we put in the star ahead of the variable name, that tells C, because I'm doing int star, this is a pointer to an array. Then we're going to reference that using the name numList. The pointer to a place in memory, we're going to use that as memory. And how long is it? We probably should on to how long it is. So numList len is, let's make it 10 numbers long, because as we did before, I need a variable to count with, and we'll use I. So let's, what do we do here? This is what declared the pointer to the array. That was step one. So how do we allocate memory to the array? Well, so allocate memory. So we're going to use a function called malloc. What's it mean? Well, we're going to allocate, we're going to allocate memory. That's why it's called malloc. We're going to allocate memory into an array. And it really needs to know, this is a function, so it needs to know how big it is. How much space should it use? Well, how many elements do we have? Well, we've got numList len, number of elements. And then how big is it? Well, each size, or each size of or each element in that array is an integer. And how big is an integer? Well, there's a macro that you can use. It looks like a function, but it's actually a macro. That's size of. And size of int will tell you, or will tell the compiler how big an integer actually is. So when I do the final math of numList times size of int, that basically is telling the compiler, or telling the computer to reserve through malloc enough space for 10 integers, or numList len number of integers. And I need to put that into a variable. And so I'm going to put that into numList. And technically, malloc is going to return a variable of type void. And so we haven't talked about void before. Void just really means no particular type in this case. So we actually need to do what's called a cast. And I haven't talked about casts before. And you put casts inside parentheses. And here we're going to call it an integer, but it's really an integer star, right? That's what we have here, integer star, because that's really what our variable type is up here. If we didn't have that, we'd probably get a warning when we compiled our program. So we're going to do a cast to integer star from what gets returned from malloc. And malloc will return then a pointer to the array that, or to the space and memory that's been reserved, allocated through malloc to store that much data. And yeah, we are actually kind of building an array ourselves, right? In other programming languages, you just say, hey, this is an array and it's of X size. But in C, you actually need to say, I need to have you reserve this much memory and set a pointer to it so I can use it as an array. And that's the difference between C and other programming languages. Now, on a low memory system, that return or that function might fail. I might not have enough memory. Or if I'm allocating a lot of memory, that probably is going to give me a problem. So how do we know that malloc succeeded or not? Well, if it returned a value into numList called null, all uppercase, that means that, oops, that's not single equals, that's double equals, right? If it returned a value of null, that means that malloc failed. So in this case, I'm going to just say if it actually returns that, then I'm going to print out something went wrong during malloc. Okay, I'm going to print out. And then I'll probably need to exit back to the operating system, so we'll return 1. When I'm so what have we done here? We've actually done in this one line the last 2 steps of allocating memory, right? Step 1 was declaring the pointer to the array. We did that up here. Allocating memory to not to store all elements of the array. Well, that happened in the call itself to malloc, right? That was what allocates the memory. And then setting the pointer to it, that happened right here. Setting the pointer to indicate that array was just through numList equals and then the cast, and that way it goes in the right variable type. So that's how we allocate memory. After that point, we can certainly loop through. So let's go ahead and loop through the array. And we'll just do a quick demonstration here just to show that it works. So we're going to do I equals 0, because all arrays start at 0. And then I needs to be less than numList len. And then I equals I plus 1. And we're going to store numList I equals let's just put in a number, and we'll put in I. Actually, let's put in I plus 100. So that way we know actually something got put in there. We're not just counting out the numbers themselves. So it'll be we'll see 100, 101, 102. Right? That's actually we're just doing a quick test here to put in something other than just I. Let's go ahead and print that value out. So we're going to do a printf. numList %d is now, we'll print out the value, and then we'll put in I, and then numList I. That'll now print out the value of that element in the array. So we're doing it as we go. I could create another loop to print out the values, but as long as I'm doing it, we'll just do it all at once. Now, before I return back to the operating system, right? Normally I would just say, okay, go ahead and return 0. You could do that, but if you're allocating memory, best practice is always, if you're going to allocate memory, you need to tell the operating system when you're done with it. So we're going to go ahead and free our memory before we exit. And how do we do that? We actually tell the operating system or tell the system that we no longer need that memory by just using the function free, and we're going to give it the name of the array, numList. So real quick, what's that doing? We are have an array variable called numList. We have another variable that's going to store the number of elements that we want to put in that array. And then I've got a counter variable. I'm going to allocate memory for the array. If I got back null, that means something went wrong. So we're going to print out a message and then just exit the program. And then we're going to loop through the array. We're going to loop through all elements of the array from 0 to numList -1, right? Because if there's 10 elements in the array, it's going to go from 0 to 9. And that's why where I is less than the length. We're going to just store an element in there. It's going to be 100 plus whatever I is. So we're going to go from 100 all the way up to 109. And then it's going to print out the value that we just put in that variable, that element of the array. And then we're going to free up our memory when we're done. Now, the malloc function is not actually defined in standard IO. That is defined in another header file called standard lib. So we need to include standardlib.h. And that should be it. So let's go ahead and save that file. I16 GCC. I'm going to turn on all warnings to make sure I didn't do anything wrong. And we're going to store it in pointers.exe. We'll compile pointers.c. All right, looks like I didn't make any errors, so that's good. So let's go ahead and run pointers, and let's see if our program works the way it should. There we go. So we've allocated our memory. It then ran through that array and stored the values 100 to 109, and then it freed up the array and exited quietly back to the operating system. If the reason I like to store the size of my array is, what if I didn't want to have 10 in there, but I wanted to have 17? Go ahead and save and quit. File, and then rerun. Right, so now I've got 17 elements, 0 through 16. And that's kind of the basics of doing pointers for an array. Now, you can use arrays for all kinds of things. Before, we'd used sort of that simple arrays that are of a known size when we compile it, to store things like, well, the 10 element array that we did in array.c. We did a simple example using a string in strings.c. But remember, strings are just arrays of chars. So we could use this allocating memory using malloc to store string data as well. So let's do another example. And I'll do this one as a string test.c. Okay. So we need to include standard IO, printing information out to the screen. We're going to be using malloc and free, so I need to have standard lib, and then my main function. So what do I want to do with this? Well, let's write a program that will create a string, and then it will copy some values into that string. So I'm going to need a string pointer. We're going to use this one. I could just do a char and then string, and then I could do that. I could do that, or I could actually tell it how wide I want it to be. I could do that, or in this case, I'm going to actually do it's a pointer, use the malloc feature. So how big do I want this to be? Oops, not even a char. It's actually an int, right? Hello, or a string size. How big do I want that to be? Well, you could do lots of things in strings, and so I generally reserve quite a bit of room for strings. We'll make this one 80 characters wide. How long is the string actually? We're going to do this later in the program, so I probably should hold on to the length of that string, and then I'm going to need to iterate through a loop later, so I'll just do an int I. So let's first of all allocate our memory. So I'm going to put into hello a character string. I'm going to cast it as a char star, right? I use malloc. And so how big is my memory? Or how much room do I need to reserve? Well, I need to reserve the string size. I said hello because what I've got written down in my test program says hello, but it's really string. So it's string size times how big is each character. So let's go ahead and do size of, and before I did size of int, size of int because it had an integer array, but this is a character array, so I do size of char. Now on most systems, size of int and size of char are probably going to be the same size, but always make sure you've got the right variable type. Now, how do I know that that failed? We'll go ahead and do a test here. So if string was null, that means it failed, right? So print out message here that just says put s. Oops, couldn't allocate memory with malloc. and we'll just return back to the operating system. Remember, when you turn back the operating system, 0 typically indicates a success when you're doing back the operating system, but anything not 0 typically indicates some kind of error. So I'm returning 1 in this case. Now let's go ahead and do something with this. I want to copy some values into that string. So when I did this in the hello program earlier, I initialized, if you remember, I initialized it with char hello, something like that, right? I can say hi there, right? That's how you could initialize a variable or a string to have a certain value in it. But now that I've used malloc to allocate it, I actually need to copy values into that string. I can't just say like with an integer where I could just say a equals 2 to put the value of 2 into a. I actually need to, because it's an array, I need to have something that's going to copy a whole bunch of individual characters one at a time into my array. So I'm going to do a function here called string copy. String copy, and I'm going to have it put into string. And we're gonna. What do I want to have it copy in there? Well, probably hello world. Put that in there, and then we could just say, okay, yeah, go ahead and do that. But it turns out that's a very dangerous thing, right? So hello world is what is that? That's 12 characters long if you include the null. And I left 80. This string is going to be 80 characters wide, so I certainly have enough room for that. But what if I didn't have 80 characters? What if I defined this as 8? Trying to copy hello world in there would actually overflow the amount of space that I had reserved. C will happily do that, and that's a problem, and you do need to pay attention to that. So whenever you copy strings, it's best to have some sort of limiter that says only copy up to string size, because I don't want you to go more than that. So that's how I'm going to copy that string. Now we can go ahead and do a put s on just string. And once we're done, then I can free the memory of the string, and I can return back to the operating system. Comment my code to make sure I remind myself what I'm doing, right? Free the memory. Then this is copy a value into the string. Okay. Now let's write this this function, string copy. So let's go ahead and we'll write it up here. So what is this going to do? Well, let's do a we're going to do a function that is didn't set a return values. I guess we'll do void, right? Because we learned earlier that malloc technically returns what's called void, which really means no particular data type. So if I use void up here as the type of my function, that just means it's not going to return any data. So we're not going to have a return 1 or return 0 or some return with a number next to it. It's going to be return. Or I just wait until it hits the end of the function. That'll work too. String copy. And then I want to actually tell it that there's a string in here. So char, and this goes into destination. And then I also had a source, and then I had a max size. So that's the function that I'm writing up here. It's going to do a string copy into a destination string, and the string is just an array of characters, so that's why I've got char star. It's going to copy from the array or the string of source, and I'll do it up until I hit a null, but I also will copy up to a maximum of the of max size. So let's go ahead and write a function to do that. Probably should have a variable to work with. That's going to be int I. I like when I write this kind of function, I like to first fill it with nulls. So I'm going to fill the destination with nulls. So I'm going to do for I equals 0. I needs to be less than max size, right? How big it is. And we know that we have at least that much room because at least that's what we were told when we did the function. And then I equals I plus 1. And in each element of that string, I'm going to store a null value. Just a single character that's in a null. And so I'm just storing in into each element of the destination string that single character. And I'm doing a single character because a string is just an array of chars. Now I don't have to do this. In fact, there's another library function we'll learn about in a second that kind of does all the stuff for you behind the scenes, but this is kind of how you'd build it yourself. Now, let's go ahead and copy source into the destination string. So I'm going to do I equals 0. I'm going to just reuse that variable I. We'll start I at 0 because that's the beginning of the string. And then while, so I'm going to do a while loop of some kind. So what goes inside my while? Well, I want to make sure that the source isn't a null variable. But I also want to make sure I'm not going to overrun the string itself. So I probably want to have another thing in here that says and I is less than max size. So I've got two different things in my while test. One of them is making sure that the character that I'm looking at in the array is from the source isn't a null, right? Because when I reach null, then I'm done. Because we're using null terminated strings, and making sure that we're not going to go beyond max size. And then all I'm going to put in here then is dest. Oops. I is source I. And we're going to increment I equals I. And then it's going to hit the end of the function. If I wanted to return a value, actually, I could return a value here. I hate writing a function that's a void. As long as I've done the work, I might as well have it do something. So I'll have it return the number of characters copied, right? Return I. And so up here, it's not even a void function anymore. This is an int function. That's just me. Whenever I write a function, I hate to just write a function that doesn't do anything or it doesn't return a value. I've done the work. Let's actually return that hard work back to the system. And whether or not I use it, I guess. But there you go. So let's go ahead and compile this. So to remind ourselves what we're doing, we've got a pointer to a character pointer called string. We've got a variable called string size that's going to be set for how much memory we want to have set aside for that string. We have another one that actually tells us how long the string is. I didn't actually use that one. But we can use it later, I guess, if we need to. But the and then int I, that's our string copy. It's our iteration rather. We've allocated the memory and put it into string. And we've done a test here, right? Because if it didn't work, it's going to return null. So now string is going to have null in it. And then if that happens, we're going to print out a message and just exit immediately. If it works, then it's going to go beyond that. And so we're going to copy the values into the string. and then it's going to print the string out. And as long as we're there, let's go ahead and let's do string len in strlen of string. We'll just print that out and say, okay, print f. We'll say inside these brackets so we can see it is characters. So this is going to tell us how long that string is. So what is the string? The string is string, and how long is it? It is string len. And then we're going to go ahead and free the memory, and we're going to exit back the operating system. Now I've done a strlen call, so I actually need to have up here at the very, very top of my file, I need to include string.h. Let's go ahead and compile that and see if that works. I16 GCC. We're going to turn on all warnings to make sure we didn't make any errors. If we did, it'll let us know. And then we're going to output it into stirtest.exe, and we're going to compile stirtest.c. And I have an unused variable in my main function. Oh, I didn't actually use it, did I? Well, that's okay. Let's go ahead and run stirtest. And there we go. We created a variable as a pointer, and we stored the value hello world into it using a copy function. And then we printed that back out and said how long it was. Now that string copy, again, just like string length is an important function to have, we can, there's actually a function in the standard C library that will copy a string from place to place. So let's go ahead and get rid of this function because we don't actually need it. And so over here we did string copy. So there is actually one called, I'm going to just put in a comment because I don't want to actually use it because it's kind of dangerous. There is one called strcpy, right? strcpy. And it looks like we're going to put it into the destination, and we're going to actually give it what we want it to copy from, and we'll give it the string of hello world. And that's how you use string copy. It makes the assumption that this array, this string, is long enough to hold what you're trying to put into it. But remember what I said before, what if string size was only 8 characters long and I'm trying to put hello world into it? That's going to be bigger than my string. So a better way to do this is with a similar named function called strcpy. It's the same thing as strcpy, but we put an n in there, and that indicates that we're going to give it the size of our string. That's going to be at the end. So I don't need the I variable. Let's go ahead and get that, and now we can go ahead and compile. Quit. And I shouldn't have any errors. And then we do stirtest, and it works exactly the same. I'm going to pause there, and I'll do a bonus video with a couple extra stuff in it. If you're a member of Patreon and you are following along at the C programming level, you'll have access to the C programming guide. Before I exit, I just want to remind everybody that this channel is definitely supported by my patrons on Patreon. Everyone who contributes to Patreon, I really do appreciate your help. Some of you have contributed at a higher level, and so I wanted to recognize you here. Thank you very much. And what did you think about this video? Let us know in the comments below what other topics you'd like me to cover. Visit our website at freedos.org. Visit us, join us on Facebook, follow us on Twitter, and consider supporting me on Patreon. Thank you.